In this video, I will record some examples of derivatives of transcendental functions. So in this first one, the first thing to notice is that we have a cosecant function. And so we've got a formula for a derivative of cosecant of u, where u is a function of x. And we notice that the function of x is right here, x squared. And this is when it is with respect to x. So we've got the negative of cosecant of u times the cotangent of u multiplied by the derivative of u with respect to x. So in all of these types of questions, the first thing we want to establish is what is u, all right? What is u? And by following this pattern here, since it's cosecant u in the formula, and our equation is cosecant x squared, u equals x squared. Right there. And we're always going to need the derivative of u with respect to x, the du dx. So du dx is 2x. All right, so now we have all the parts that we need, because in the derivative we want to fill in the u and we want to fill in the du dx. So let's go ahead and we'll write our derivative f prime of x is equal to, now the 8, it's a multiple, it's not really part of the cosecant, it gets brought down, just carry down whatever the coefficient is, 8. Now we are taking the derivative of cosecant u. That's where this formula all applies, all right? So let's just square bracket it because the 8 is not in there. And we want to make sure we do the negative. Cosecant u, we'll fill in what u is. U is x squared. Cotangent of u again, that's still x squared, multiplied by the derivative of u with respect to x, 2x. All right, so now the last thing is, well, we just want to tidy this up. Take a look at some things that you won't be touching, okay? Cosecant of an angle, they stay bound together. We're not going to interfere with that. Cotangent of an angle, we won't interfere with that. However, the rest that we can tidy up is 8 times -1 times 2x. So the f prime of x, and I'm just going to write that again, although I could just write equals 8 times -1 times 2x is -16x. Cosecant, it's not cos, cosecant x squared, cotangent x squared. And that's how we will leave it. Now, here's another one. I've given you the function we want to find the derivative of. I've given you the equation for the derivative of secant u by dx. And so what I would suggest right now, if you followed what I did in the previous example, pause the video and give this one a try. And now that you've had a chance to try it, I'm going to fill in the answers. So I'll use over here. So u, what is u? We always ask ourselves, what is u? In this case, secant u. Oh, it's secant 6x squared. So u equals 6x squared. What is du dx? Because we need that too. So du dx is 12x. All right, we're all set. So let's do our answer. F prime of x is 15 is just multiplied by secant u, so secant 6x squared. We never change the angle, remember that. Tan 6x squared multiplied by du dx, which is, whoops, I should say 12x, multiplied by 12x. So 15 times 12x, 180x secant 6x squared tan 6x squared. All done, okay? Because remember, we're not going to touch that. We're not going to touch that. But this one and this one can get multiplied together to form the coefficient. Okay, again, I've got another one. This one is a cosine function. Now, the only difference with this one is I have added one more, in a sense, layer to what's happening in this function. This is to the power 4. So I would suggest that this be rewritten as f of x, this is not the derivative yet, 10 times cos 3x cubed all to the power 4, all right? This means the same thing as 10 cos to the power 4 of 3x cubed. The order of operations is cos 3x cubed first, raise that to the power 4, then multiply by 10. All right, so I always suggest if this throws you off, okay, seeing that exponent there, rewrite it this way. And now think about all the things that are happening to x. X is getting cubed and multiplied by 3. There's one layer we'll need the derivative of. Then we're taking the cosine of it. That's one layer we'll need the derivative of. That's done with this formula. And then it is raised to the power 4 and multiplied by 10. That's another layer we will need the derivative of. So if you think you know what to do, go ahead and pause the video and give it a try. I'm going to go ahead and do this one now. My f prime of x is, so this is, the outermost layer is 10 something to the 4. The derivative of that is 4 times 10, right? So we multiply exponent by coefficient. Leave the bracket alone and reduce the exponent by 1, right? That's a regular power rule for derivatives. Now, we need the derivative of inside. Now, this is like previous ones that we have done. So, we do the derivative of a cosine function is minus sine of the same thing. So, I'm going to bracket it again. Minus sine of 3x cubed multiplied by the derivative of 3x cubed, which is 9x squared. So to tidy that up, take a look at what we are not touching. We're not touching the cosine 3x cubed. We're not touching the sine 3x cubed, but we do have a 40, a minus 1, and a 9x squared. So multiply those things all together, and it is minus 360x squared cosine 3x cubed, that's all cubed, and sine 3x cubed. Now if I want to put this part back in the original notation, kind of like this, it will look like minus 360x squared cosine cubed of 3x cubed sine 3x cubed. And that's complete. Here's another one that's very similar. So I suggest you pause the video and give it a try. I haven't written the formula, but the derivative of sine u with respect to x is cos u du dx. All right, that was the first one we learned with the trig function ones. So go ahead and give that one a try, noting that we do have a power 5 there. So that adds that extra layer of derivatives that we need to do. All right, so I'm going to rewrite that as usual. 6 sine 2x to the 4 all to the 5. All right, so this is 6 something to the 5. I want the derivative of 6 something to the 5. Well, 5 times 6. Leave the bracket alone, the something. Oops, that's not a square, that should be a 4. And reduce the exponent by 1. Now, because inside the bracket is not just an x, we need the derivative of what's inside the bracket, right? We're going to go out here and do its derivative. The derivative of sine 2x to the 4 is cos 2x to the 4 times the derivative of 2x to the 4, which is 8x cubed. Very much like the previous one. So think about the parts that we can multiply together to form the coefficient. So that is going to be the 30 times the 8x cubed. All right, so that becomes 240x cubed sine power 4 of 2x to the 4 cos 2x to the 4. Okay, here's another one, another added dimension to it. Now, we're always thinking about how many functions of x are we dealing with in here, and notice that we have an x multiplied by cosecant x squared, not just a number like 10 cosecant x squared or 8 like the first one. So we have a split that has to happen right here, which means we are dealing with derivative of a product. So we need the product rule. That means we want to establish for the product rule u and v. This is different from the u that we will use to find the derivative of this one. So let's just keep those separate. I'll use different colors, okay? So for the product rule, I'm going to use, I've already written that part in blue, so I will use the blue for that. So u is going to be the first factor, and v is going to be the second factor. Actually, we'll put it down lower. Du dx is going to be the derivative of x, which is 1. So v is going to be the second factor, cosecant x squared. And the dv dx is the derivative of that. That's where we need this one. So I'll do that part in green. This is a different u, okay? So that is going to be minus cosecant of x squared cotangent x squared, and sorry for going to another line, multiplied by du dx, a derivative of x squared, which is 2x. So let's just tidy this. Hold on just a moment. I will make it a little more room. So the dv dx is minus 1 times 2x. So minus 2x cosecant x squared cotangent x squared. Now, those are all the parts for the product rule. Let's go ahead over here, and maybe I can use this color. Let's see. So f prime of x instead of blue. For the product rule, we want to multiply u by dv dx, right? So x times dv dx, which is minus 2x cosecant x squared cotangent x squared plus the v times du dx, so 1. So cosecant x squared times 1. I'll just write that this time. I don't really need to, okay? To tidy that up, f prime of x, move it right over so we have lots of width, okay? The first term, I want to multiply that by that, which becomes minus 2x squared cosecant x squared cotangent x squared plus cosecant x squared. And that's how we can leave it. Some people might want to look at the common factor and factor out the common cosecant x squared. So if you want to see that, which you don't have to, factored, we'll just write it, but I don't require it. F prime of x is, now the common factor of cosecant x squared occurs in both of these two terms. So we'll factor out a cosecant x squared. That leaves minus 2x squared cotangent x squared plus 1. So that's a possibility, but I don't require it, okay? That was the product rule because we have two separate functions of x, so you do require the product rule for that. Okay, so here's another one of the transcendental functions. It has a logarithmic function. So notice that the derivative of log base b of u, so u is going to be the function of x, so that's right there, with respect to x dx, is 1 over u log base b of e times du dx. So we need to know for this one, not just what u is, but what b is. So let's take a look at our pattern, okay? B is the base, so b equals 8. U equals 2x cubed. And du dx equals 6x squared. All right, going to our formula. F prime of x equals, just a 7 gets multiplied down, nothing else. We'll multiply that in after. The log base 8 of 2x cubed fits the log base b of u, so we do this formula 1 over u, 1 over 2x cubed, times log base 8 of e. Make sure when you're writing it, this imaginary line that sits on 8 is a subscript, okay? And multiplied by du dx, which is 6x squared. Now, we want to make sure that 6x squared doesn't get multiplied by e. That's why I put a square bracket there. We don't want that, all right? So, but we can. So this is kind of going to get left alone, just like a sine u, log base 8 of e. We're not touching that part. However, the other values can all get multiplied together. 7 over 1, 1 over 2x cubed, and 6x squared over 1. They're all going to get multiplied together. So I'm going to write it the long way. I got a 7 times 1 over 2x cubed times 6x squared over 1 times log base 8 of e. Let's fix that e. All right. 7 times 6, 42x squared over 2x cubed times log base 8 of e, and 21 over x times log base 8 of e. Okay, the 42 over 2 reduces to 21 over 1, and x squared over x cubed is 1 over x. So that one is complete. We talked about this in class. I'm not going to get into that right now. Okay, so a couple more. You may be starting to see the pattern that emerges in all of these different transcendental functions, that the u is always a function of x. And so we ask ourselves in every single one, what is u? And so this is a natural logarithm function. So I'm looking at the natural logarithm derivative. Since I've given you the formula, go ahead and see if you can follow the pattern. Pause the video and give this one a try. All right, so u equals, we're taking the ln of 6x squared, so it's ln u, so u is 6x squared. Du dx is 12x. All right, f prime of x. We have a multiple of 3 in front. I'll square bracket it. Now I'm looking at this part, okay? And so I'm doing this to it. 1 over 6x squared, that's 1 over u, times du dx times 12x. Now remember, that's over 1, okay? So now let's just multiply all together. 3 over 1 times 1 over 6x squared times 12x over 1 That is 3 times 1 times 12x, 36x, over 1 times 6x squared times 1, which is 6x squared. Reduce, that becomes 6 over x. Okay, one last one for this video. Now let's see, I've given you the formula up here for the derivative of e to the u with respect to x. Pause the video and give it a try. I will fill in the answer. All right, so it is e to the 5x squared. The u is 5x squared. The du dx is 10x. We're all set. Our f prime of x is going to be 10's a multiple. Just multiply by 10. If you want to separate by a square bracket, that's okay. We are now doing this part, which fits this part. All right, so that is e to the u times du dx. So it's e to the 5x squared multiplied by, oh, maybe we'll just do it this way, multiplied by 10x. That square bracket could actually go after the, maybe we'll put that here instead. That seems a little better. Now, remember, when we're simplifying these, there's parts of it that we don't touch, the exponential part. No, we're not going to dig into that. Leave it alone. But 10 can be multiplied by 10x. So this f prime of x becomes 100x e to the 5x squared. And we're finished. Okay, so that's a bunch of examples on derivatives of transcendental functions. Hopefully that's helpful. Just remember, the question is, we're asking ourselves each time, what is u? In the logarithm ones, we've got a base b to account for as well, but keep those derivatives handy and you will be able to use a formula to find those derivatives. Thanks for watching.